The concept of power, part two. Our other definition for power is the rate at which a process transfers or transforms energy. So here are some example processes and the approximate power associated with them. A cell phone flashlight is going to transform chemical potential energy in the cell phone's battery into electromagnetic energy, this yellow orb here, in the form of visible light. Light is a form of electromagnetic energy. And that little bulb there is going to convert chemical potential energy into electromagnetic energy at a rate of about 1 joule per second, or 1 watt. A microwave oven is going to start with electromagnetic energy in the form of electricity and convert that into, well, a different kind of electromagnetic energy, microwaves. And it's going to do that at a rate of about 1 kilowatt, about 1,000 joules per second. Every second that your microwave oven is running, 1,000 joules of EM energy in the form of electricity is being converted into 1,000 joules of EM energy in the form of microwaves that are delivered to your food. Scaling up, a diesel locomotive is a engine that will transform chemical potential energy in its hydrocarbon fuel, its diesel fuel. Chemical potential energy stored in that fuel will get transformed into the kinetic energy of the moving train at a rate of about 1 million joules per second. That's about 1 megawatt, or several megawatts would be the power output of the diesel engines operating such a locomotive. At the next highest scale, we have a nuclear power plant, which is going to be transforming nuclear potential energy stored in the uranium fuel into electromagnetic energy, into electricity, as the plant generates that electricity. And every second that the plant operates, it's going to convert about 1 billion joules of nuclear potential energy into electromagnetic energy, into electricity. That's 1 gigawatt. So the power output of a big nuclear power plant is about a gigawatt. That's the kind of power that can power a small city. Horsepower is a common English unit for power, an alternative to watts. Some brief info here on horsepower. The SI unit for power is the watt. A watt is a joule per second. The English unit is horsepower. 1 horsepower is equivalent to about 746 watts. Although there's also something called a metric horsepower, which is slightly different, about 735 watts. The name suggests what it is. It's related to the rate at which a draft horse could do work back in the days when draft horses assisted with mining, helping to lift loads or operate pumps to drain water out of mines. So picture a horse in a harness attached to some load that it's lifting over a pulley, and the rate at which the horse can add potential energy to that load is the power output from that horse. So 1 horsepower is roughly based on how the power output from a healthy draft horse. And it's a unit that we still use today. The power outputs from automobile engines are often given in terms of horsepower. So you see some examples here, down to this Lamborghini with almost 700 horsepower, which would be about the equivalent of about 500 microwave ovens. 500 microwave ovens, that's your Lamborghini here. You, a person, a healthy human, can produce just over 1 horsepower briefly when you're running or exerting yourself. But you can sustain about 1/10 of a horsepower, about 75 watts indefinitely. So working over a long period of time, you can comfortably put out about 1/10 of a horsepower. In brief bursts, you can put out just over 1 full horsepower, just equivalent to a horse. Human can be equivalent to a horse just briefly for a moment, but mostly we're 1/10 as powerful as a horse. Trained athletes, however, can manage up to about 2.5 horsepower briefly, and 0.3 horsepower over a period of several hours. Usain Bolt produced a maximum of 3.5 horsepower at a particular moment into his 9.58 second 100 meter dash world record in 2009. Info I got from Wikipedia there. More on power. You'll also encounter the unit in everyday life, kilowatt hour. A kilowatt hour is a common industry unit for energy. A kilowatt hour represents an amount of energy. It has watts in there, which makes us think power, but it's watts times hours, power times time, which actually represents energy. So 1 kilowatt hour, note lowercase k for kilo, capital W for watt, lowercase h for hour. A kilowatt hour, 1 kilowatt hour, is the amount of energy that's transferred by a process that averages 1 kilowatt of power output operating continuously for 1 hour. So I suppose if you had a 1 kilowatt microwave oven and you set that microwave to run for 60 minutes, then the amount of energy that that microwave would put out during those 60 minutes in total would be 1 kilowatt hour of energy. Here's our conversion. 1 kilowatt hour multiplied by 1,000 watts in a kilowatt and by 3,600 seconds in 1 hour. 3,600 seconds is 60 seconds in a minute times 60 minutes in an hour. And then since a watt is a joule per second, 1 watt times 1 second equals 1 joule. So canceling kilowatts, canceling hours, canceling watts, and canceling seconds, we get 3,600 times 1,000, so 3.6 million or 3.6 megajoules. 3.6 megajoules. 1 kilowatt hour is an amount of energy equivalent to about 3.6 million joules or megajoules. And you can put a price on energy. This is important to know in life. You can be charged for, you can pay for, or you can sell chemical potential energy in the forms of various fuels, nuclear potential energy as a fuel, if you can get your hands on some uranium. You can also put a price on, buy and sell electromagnetic energy in the form of electricity. So I've got a practice problem coming up for you here. You're going to pause in a moment and work this out based on what we've discussed. Suppose your electric utility charges you 20 cents per kilowatt hour for supply, delivery, taxes, and fees. So the bill you get every month shows that you're being charged 20 cents per kilowatt hour. Remember, kilowatt hour is an amount of energy, so you're being charged dollars for the energy that you use. Question is, what will be your bill if you run a 1.2 kilowatt microwave oven for 3 minutes per day, every day for 30 days? You're being charged that rate. This is your usage. How many dollars will you be charged on your bill? Pause the video and use the preceding information to work that out. Got it? Here's our answer. Method 1 of finding this would be to start by computing the amount of joules of energy that has been transferred to you, the user. So 30 days, you're running this microwave oven for 3 minutes every day. There's 60 seconds in a minute. So that's 5,400 seconds total operating time over those 30 days. When your oven operates, it outputs energy at a rate of 1.2 thousand joules per second. So 1,200 joules per second for your 1.2 kilowatt oven. So if it's 1,200 joules per second times a total running time of 5,400 seconds, that's 6.48 megajoules, 6.48 million joules of energy that have been transferred to you, that you have used as the consumer. So we take that 6.48 megajoules, we'll need to convert that to kilowatt hours because we're being billed per kilowatt hour. So 6.48 megajoules times our conversion of 3.6 megajoules in 1 kilowatt hour. 1 kilowatt hour, 3.6 megajoules, to find out that you have used 1.8 kilowatt hours by running your microwave oven that long. So the cost to you, the consumer, is the 1.8 kilowatt hours of energy you used times 20 cents for every 1 kilowatt hour you used. Therefore, your bill is going to be 36 cents. It is not expensive to operate a microwave oven. 36 cents for that month, running it for 3 minutes a day. And another method of getting to that same result somewhat more efficiently would be this here. Let's stick in terms of kilowatt hours since that's how we're being billed. So we'll find that if you run your microwave for 30 days, 3 minutes per day, and 60 minutes in an hour, it's 1.5 hours total operating time. So instead of converting to seconds, let's just stick with hours, 1.5 hours total operating time. It's the same as this 5,400 seconds, but stick with 1.5 hours. Your 1.2 kilowatt oven operating for 1.5 hours, that's kilowatts times hours. That gives us kilowatt hours right away in one short step. So 1.8 kilowatt hours of energy was used by your oven, and you're being charged 20% for every one of those kilowatt hours. So 36 cents is your bill.